Hey guys, Mr. B here, and in this video we're going to be going over the practice problems in chapter 3.4 on density. Alright, let's get started. Number 1, the ratio of the mass of an object to its volume is its blank. So this is directly from the notes. This, of course, is what we call density. If I can type. Number 2, density is an blank property that depends on the blank of a substance, not on the size of the sample. So again, this is also directly from the notes, but density is an intensive property that depends on the composition of a substance, not the size of the sample. Okay? All right, moving on. Number 3, let's undo that. All right. Number 3, a bar of silver has a mass of 68 grams and a volume of 6.48 cubic centimeters. What is the density of silver? Okay, so this is just a basic density problem. We are given, so here again, here's what we know. So we know, your known values, we know mass, which is 68 grams. We know volume, which is 6.48 cubic centimeters. And they want us to find density, which we don't know. Now remember that density is equal to mass divided by volume. There's some stuff here. Let's just ignore this. Ignore. There we go. So we have density is going to be equal to mass, in this case, is 68.0 grams, divided by volume, which is 6.48 cubic centimeters. And we're just going to do this basic division on our calculator and get an answer. So 68.0 divided by 6.48, and we need to round this to 3 significant figures because of the numbers that were given. So if we round this to 3 sig figs, we get 10.5 grams per cubic centimeter as our final answer. There you go, and that's it. All right, number 4, true or false, the density of a substance generally decreases as its temperature is increased. So this is true. This is, again, directly from the notes, but remember that density and temperature are opposites. So as density goes down, temperature goes up. As temperature goes down, density goes up. So they're always going to move opposite from each other. Number 5, density can have units of grams per cubic centimeter. Yep, that is 100% true. I think this is supposed to be a true or false question, by the way, and I don't know why it's not there. On mine, it will be there on yours, though. So let's just add in here, true or false. True or false. Okay. Number 6, use dimensional analysis and the given densities to make the following conversions. Okay, so we're given 14.8 grams of boron. They want us to convert this to cubic centimeters of boron, and they give us the density of boron as 2.34 grams per cubic centimeter. All right, so let's set up a text box. I don't know where the best one to do it. Maybe just over here, I guess. And just leave our font size as maybe like 14. That's probably fine. Okay, so using dimensional analysis, we're going to start with 14.8 grams of boron, and we can do it over 1 if we want to, and we're going to use our densities as our conversion factors. So we're going to be converting from grams to cubic centimeters. So since we're starting with 14.8 grams on the top of our fraction, when we use our density as our conversion factor, we need to flip it so that the 2.34 grams, rather than being on the top, is going to be on the bottom. So when we write it here in this portion, we're going to have 1 cubic centimeter on the top, and we're going to have 2.34 grams on the bottom. Okay? And again, we're going to do this so that grams is going to cancel with grams. And then we just need to do our math out. So take 14.38 divided by 2.34. Or 14.8 divided by 2.34. And then we're going to round this to 3 significant figures based on the numbers we're given. So this should be 6.32 grams. Just 6.32 cubic centimeters. Because this is a volume. And the units we have here are cubic centimeters. So this is our final answer. Maybe we can make this a little bit bigger in terms of font size. Let's go maybe instead of 14, go like 18. Nope, too big. Okay, never mind. We'll see it at 14. All right. Looking at the next one, letter B. Oh, I'm going to undo that part. Letter B. There we go. So it's basically the same exact problem. It's just different numbers. In this case, we have 4.62 grams of mercury, again over 1 if we want to do it that way, times times 1 cubic centimeter over 13.5 grams. Again, we're going to do it this way so that our grams will cancel out with each other, just like we did in letter A. It's pretty much the exact same math. And then we'll just take 4.62 divide by 13.5. And again, rounding to 3 significant figures, we get 0.342 cubic centimeters as our final answer. Just underline this and turn it black. And there we go. That's it. So just simple, division problem. All right, the last one here, number 7. A container has a mass of 100 grams when empty, 250 grams when filled with water, and 200 grams when filled with an alcohol solution. Calculate the density of the alcohol solution if the density of water is 1 gram per milliliter. Okay, so this one is a little bit tricky, and just by reading it too, you might be like, I'm not sure even how I start this one, but I will show you. Okay, it's not as hard as you think it is. You got to do a little bit of thinking. So let's move our text box up here so you have a little bit more space. And yeah. Okay, so here's what we want to do. So we are given some information, and this information is really important, okay? So we have a container that when it's empty has a volume of, when it's empty, has a mass of 100 grams, okay? Or 100.0 grams. The water, when it's filled, is 250 grams. So when it's empty, it's 100. When you put water, it's 250. It basically gives us the mass of the water. So we're gonna say the mass of the water is 150 grams. Okay, just because the container is 100 grams empty, 250 with water in it. That means there's 150 grams of water in there. Okay, and when we fill it with alcohol, so we'll say I have the mass of the alcohol is 200 grams. So that basically just tells us there's 100 grams of alcohol in there. Okay. All right. So this is the information they're telling us. They're also telling us the density of water, which we'll just put over here, I guess. So density, let's call it, density, if I can type, density of water is equal to 1.0 grams per milliliter. All right. They want us to find density of the alcohol. Okay, so this is question mark because we don't know what that is. Okay, so here's all the information we know. Where do we go from here? Well, let's think about the density equation. In order for us to figure out density, or at least density for the alcohol, we're going to need to know density of the alcohol is going to be equal to the mass of the alcohol. Alcohol, okay. We're going to need to know the mass of the alcohol divided by the volume of the alcohol. Now we don't know what the volume of the alcohol is, but we do know what the mass of the alcohol is. Okay, so we don't know the mass of the alcohol. We don't know the volume, but we do know the mass. So basically, in order to solve this problem, we need to figure out what is the volume of the alcohol. We have the mass right here, okay? So we know that this is going to be 100 grams divided by some number. So this is where the other information comes in, okay? Here's what we're going to do. The density of water is 1 gram per milliliter. What that means is if you have 1 milliliter of water, it will have a mass of 1 gram. Okay, so if we have 150 grams of water in this container, that's going to be equal to 150 milliliters. Okay, and here's how we can use this. The water and the alcohol are both being put in the same exact container. Therefore, we can assume that they're both going to be filled to the top. So if there's 150 milliliters of water in this container, when you put alcohol in the container, there's going to be 150 milliliters of alcohol. Because remember that liquids will take up, the volume of a liquid will take up whatever container you put it in. And the container in this case is the same in both. So this basically tells us that we have 150 milliliters of alcohol as well when you fill this container with it. And so at that point, we now know what the volume of the alcohol is. So we can find our density by taking 100 grams of the alcohol, based on the information they tell us in the beginning. And we are going to divide that by 150 milliliters. Oh, my bad. Did not mean to do that. Divide by 150 milliliters, and this will give us our density. Okay, so we're going to take 100, divide by 150, and we'll round this to, I guess, 4 sig figs. So 0.6667 grams per milliliter, because it is a density. And that is the density of our alcohol. Okay, so again, the mass of the alcohol comes from the beginning information, and the volume was determined based on how much water was put in there, and therefore that would be the same amount of alcohol put in there. And then you just do a simple division problem, and there you go. So again, a little bit of a tricky one, but anyway. Okay, so that is it for this section of notes. If, of course, you have questions, you're confused, you still need some help, reach out to me, okay? Email me, talk to me in person in class. We could always do Google Meet or something, but make sure that you get your questions answered. Don't sit there confused. All right, guys, this is the last section for this chapter. Next up, you have review, and after that, you'll be taking your test. So I will see you in the review video. Bye.